Hi everyone, here are your section 5.7 notes. We're going to kind of be pulling it full circle. We started some trig equations prior, so now we're just going to kind of sum it all up and make sure we're good to go with solving trigonometric equations. So a trigonometric equation is an equation that contains a trigonometric expression with a variable such as sine of x. Identities, such as sine squared x plus cosine squared x equals 1, are true for every value of the variable. So if you guys remember way back in your algebra days, if you were solving equations out and your variables canceled out and you were left with a true statement like 1 equals 1 or 2 equals 2, and then we called that an identity, which said that we had all real numbers for our solution set. So that's pretty much what your trig identities are, right? So solutions are the values that satisfy the equation. We will begin by finding solutions for one revolution from 0 to 2 pi and then expand to find general solutions for these equations. So I just want to kind of refresh. If you guys remember that one packet that I had you guys do where you had to do the graphing on the first page, I made a quick note of how to do that. We're going to go through graphically just to make sure you know how to do it graphically on your calculator. And then we'll go through it algebraically too. I'm going to be using the unit circle a lot, so I'm sure you're going to want to have that accessible very easily. Okay, so for example 1, we want to solve by graphing the equation sine of theta is equal to 1/2. So when you are solving by graphing using your calculator or just by hand, you want to graph the left side and you want to graph the right side separately, and then you want to see where they meet. Well, remember our sine curve, it's been forever. Starts at the origin, max, intercept, minimum, intercept, and it keeps following in that pattern. Okay, so we've got this curve happening for my sine graph. And then the line, y equals 1/2. Is just a vertical line that goes straight across at 1/2. Now, I may have done a good job of getting at 1/2, I don't know. So my points where they are intersecting would be your solutions, right? So here, 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 and here, and so forth, right? For this case, we're just looking from 0 to 2 pi. Are we including 2 pi? Well, no, it's not, and that's a bad look right there. That's not at 2 pi comma 1/2. Remember, 2 pi is at 0. That's a intercept there. Okay, so how do I do that on my graphing calculator? So I'm going to go ahead and pull up my graphing calculator. All right, so I'm going to go into my y equals screen, and I'm going to type in sine of x in line 1, and I'm going to type in 1/2 for line 2. And since we are graphing in radians, I'm going to turn it into radians for my mode. And then I'm going to do a zoom trig to see what it looks like. All right, so I don't have to do any zoom in or zoom out, which is great. And then I can use my calculator to calculate the intersect, right? So it's asking me to pick the first curve, hit the second curve, guess, and there's my intersection at 0.5235988. And then I can go find the other one. Oops, do that again. Second, calculate intersect. And I'm going to move my cursor over this way. Curve, enter, and then we're at 2.617. So 2.6179999 some change, and 0.588. I forget what the first one was. It so happens that they end up, your theta actually ends up being at pi over 6, which is that 5.588, and at 5 pi over 6. Okay. If I were asking you to solve it using your graphing calculator, then I would expect the decimal answers. So don't be afraid to do that. So what was pi over 6? Pi over 6 was 0.5235. Did we get 588? I feel like we did, didn't we? 5 pi divided by 6, 2.61. Yeah, that's what we got for this one. So 2.61799. And then the other one was what? 0.52359. So theta can be equal to those values just in the one rotation. If we were going a second rotation, then we'd find those coterminal angles, right? So we could just add 2 pi to both those numbers and then keep adding 2 pi to those numbers and keep adding 2 pi to those numbers, and I could keep getting infinite number of solutions. Okay, so let's go ahead and solve example number 2 using the unit circle. So we have 2 cosine x minus 1 is equal to 0. I'm going to solve this for cosine x. I'm going to add my 1 over, and then I'm going to divide by my 2. So I'm looking on my unit circle when the cosine is equivalent to 1/2. Remember, your cosine is your x coordinates. That happens at 60 degrees. And it also is going to happen down here at 300 degrees, because then I'm going to be at 1/2 comma negative root 3 over 2. Remember, these are reflections of each other over the x-axis. So what is 60 degrees? Well, 60 degrees is pi over 3. 300 degrees. Remember how to convert? Let's do that quick refresher. Divided by 180, multiply by pi. So that's 5 pi over 3. So my x is equal to, because that's my variable, pi over 3 and 5 pi over 3. If we were just going one rotation. Again, I could find infinite numbers if I just keep adding a full rotation. So finding my coterminal angles with that. All right, so let's go ahead and solve these equations by collecting like terms. So I have the sine of x plus the square root of 2 is equal to the negative sine of x. So again, I could graph the left side, graph the right side, and see where they intersect on my calculator, but it's not going to give me exact answers. So let's go ahead and solve it by collecting all the signs on one side. So I'm going to move that negative sine x over by adding it, and I'm going to subtract that square root of 2 over to, square root of 2, not 3. Combining like terms gets us 2 sine of x is equal to negative square root of 2. Divide out your 2. Tells me that I'm looking for when my sine of x is equal to negative root 2 over 2. Well, that's going to be one of our quarters, right? So sine, all students take calculus. So it's going to be down here in quadrants 3 and 4. So what are we at in quadrants 3 and 4? Well, that's 5/4, right? 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So 5 pi over 4 and at 7 pi over 4 would be our answer to x. So for number 4, again, let's move everything that has cosines to the left and all our numbers to the other side. So 18 cosine x minus 14 cosine x is equal to 7 minus 5. So that gets me 4 cosine x's is equal to 2. Solving that for cosine x gets us cosine x is equal to 1/2. So cosine x, when are we at 1/2? So again, we're looking for, so all students take calculus. So we're going to be here in quadrants 1 and 4 when cosine is positive. And we're going to be at 1/3, I think. Pi over 3 gets us 1/2. So that's at 1/2 and root 3 over 2. And then reflecting that down below gets me 5 pi over 3. So x is equal to pi over 3 and 5 pi over 3. If you had your unit circle handy, right here you could easily get that. So when is your cosine at 1/2? Pi over 3. 5 pi over 3, right? That makes it a lot easier just staring at your unit circle. Okay, so there are my answers for this one. Pi over 3 and 5 pi over 3. Again, we're just doing it for one rotation. Moving on to various techniques. Here we have 4 sine squared minus 1. Notice that I have a sine squared there. Sorry, so I could factor that using a difference of squares, potentially. Or I could solve it using square roots. That's up to you. If you solve it by factoring, it'll be 2 sine squared x plus 1, 2 sine squared x minus 1 equals 0. So then you would get sine squared x equaling negative, or sorry, not sine squared x. Get rid of those squareds. Let's say that's going to give me no solution. sine x is equal to -1/2, or sine x is equal to +1/2. So where on your unit circle are you at -1/2 for your sine? Then where on your unit circle are you at +1/2 for your sine? Well, that would get you to pi over 6, 5 pi over 6, 7 pi over 6, or 11 pi over 6. If I solve this same equation by square roots, then I would have sine squared x is equal to 1 over 4. If I add my 1, divide my 4, then when I square root both sides, I get sine x is equal to plus or minus, the square root of 1 is 1, the square root of 4 is 2, which would still give me the same x values through one rotation. Okay. Number 6, we have 3 sine squared x minus 1. Here I would definitely suggest trying to solve it by square roots. So add your 1, divide your 3, gets you tan squared x is equal to 1/3. When you square root both sides, we get the tangent of x is equal to plus or minus the square root of 1, which is 1, over root 3, right, which is the same as root 3 over 3. So now I have to figure out which ratio of tangent is going to get me 1 over root 3, or root 3 over 3. Okay, so my options are 1/2 root 3 over 2, or root 3 over 2, 1/2, right? And we know tangent has to be y over x. So if I do the first option and do my y multiplied by the reciprocal of my x, that just gets me root 3. So it's not going to be that one. So it's got to be this guy over here. If I do my 1/2 times the reciprocal of my x, then I get my 1 over root 3. So it's this one right here. So which degree or which radian is at that ordered pair? It's at our pi over 6, isn't it? So my answers are going to be at pi over 6. And then where else is tangent positive? Over in quadrant 3, where they're both negatives. So that's over there at 5 pi over 6. And then it would also be the case, let me go ahead and pull up my unit circle here so you can see what I'm talking about. Nope, that's not there. It's over here. It's at 5. It's at, I was wrong on that, 7 pi over 6. So we're at pi over 6 and 7 pi over 6. That gets you all of your positive versions. But then I have plus or minus in front of that, right? So then I'm going to need to get the other variations of my root 3 over 2. It has my x, which is over here at 5 pi over 6, and then over here at 11 pi over 6. So there are all my solutions. So 11 pi over 6, 5 pi over 6, what did I say, 7 pi over 6, and 11 pi over 6. That's you both the plus and minus variations. I almost forgot that plus and minus. All right, example 7. Here we have 2 sine x cosine x minus sine x. So I see a sine x in both of these, so my first thought process is to factor out a sine x, which leaves me with 2 cosine x minus 1 equals 0. So now I can use my zero product property and set the first equal to 0 and the second equal to 0, which is going to get you cosine x is equal to 1/2. Hopefully everybody's okay with that move. Add 1, divide by 2. So where on my unit circle is my y at 0? Well, that's at 0 and pi, not including 2 pi. So x is equal to 0 and 2 pi, or sorry, pi, because 2 pi would be the same as 0. But if we're including 0, then we're not going to include 2 pi. Where is my cosine x? So where is my x at 1/2 a pi? That's at pi over 3 and 5 pi over 3 on my unit circle. So there will be my answers for my x's for example number 7. All right, so equations in quadratic form and then bringing some identities back into our lives. So here we have the cotangent of theta, cosine squared theta is equal to 2 cotangent theta. I'm going to move everything over to the same side. So that's going to get me cotangent theta cosine squared theta minus 2 cotangent theta is equal to 0. Factor out a cotangent theta, leaves you with cosine squared theta minus 2 is equal to 0. Now I can use my zero product property, right? So we have cotangent theta needs to equal 0. Or cosine squared theta needs to equal 2, but when I square root that, I get cosine theta needs to equal plus or minus square root of 2. Let's talk about that for a moment. Square root of 2, positive square root of 2, is about 1.4. So this is about 1.41. And you guys remember from when we were talking about laws of sines, your sine ratio is never going to exceed 1 or be less than -1. Same with your cosine, because your cosine has a hypotenuse in the denominator, right? So there's no way for your hypotenuse to be smaller than the adjacent. So that's no good. That's like an extraneous solution. Remember, extraneous solutions are solutions that you get that don't work for the actual problem itself. So the only one we're working with is the cotangent theta being 0. Remember, cotangent is x over y. So I need 0 over 1, or I need 0 over -1. So at 0, 1, we're up at pi over 2. And at 0, -1, we're down at 3 pi over 2. Our answers there. All right, let's jump over to number 9. Again, I'm going to move everything to the same side. So 2 sine squared x minus cosine x minus 2 is equal to 0. In order to be able to use the zero product property, I probably want to get everything in terms of cosine. So remember our Pythagorean identity. Sine squared is the same as 1 minus cosine squared x. Minus cosine x minus 2 is equal to 0. Distributing, 2 minus 2 cosine squared x minus cosine x minus 2 is equal to 0. Your 2's cancel out. I can cancel out those negatives. So now I'm left with 2 cosine squared x plus cosine x is equal to 0. Factor out a cosine. Gets you 2 cosine x plus 1 inside. So now using your zero product property, we need to find the cosine of x is equal to 0. And we need to find when the cosine of x is equal to subtract 1 divided by 2, -1/2. So using again your unit circle, my x is 0 at the y-axis, so at pi over 2 and at 3 pi over 2. And then my cosine is -1/2 at 2 pi over 3 and 4 pi over 3. Again, unit circle is going to be your best friend, especially since you can have it in front of you this whole time. All right, almost there. So now we're going to jump to example number 10. Again, still just factoring. So if you don't remember how to factor, if you want to simplify it, just turn this into 2u squared minus u minus 1. So how does that factor? Well, we're going to have opposite signs. This has to be a 2. Well, one of them is going to have to be a 2, and one of them has to be a 1. And then I'm going to have a 1 and a 1 somewhere. So let's see if this works. This gets me -1, -2, which is -3. So that doesn't work, which means I'm probably going to have to put my 2 here, my 1 there, 1, 1. So that gets me +2, -u. So now I got to change my signs. So what does that get us do? Plus and then minus. Now does that work out? -2, yep, -1. All right, so there's our factored form using guess and check. So that goes to, what I have, sine of x minus 1 and 2 sine of x plus 1 is equal to 0. So that gets us sine x equals 1, sine x is equal to -1/2. So when is our x going to be equal to 1? Well, that's going to be just at pi over 2, right, at 0, 1. And then where is my x, or my y is equal to 1. I said that wrong. I think I said x. My y is at 0, 1. Where is our y at -1/2? If you look at your unit circle, you get 7 pi over 6 and 11 pi over 6. So those will be your solutions there. And then for example 11, we have 6 cosine squared x minus cosine x minus 2. So that's going to factor 2, 3 cosine x minus 2, 2 cosine x plus 1 when you factor it out. So now we get cosine x has to equal 2/3. It's going to be interesting. Cosine x is equal to -1/2. Let's do the -1/2 first, because we know that one from our unit circle. So 2 pi over 3 and 4 pi over 3. Now this is not on my unit circle. So how do I solve for x? Well, we have to use inverse trig. So on my calculator, I'm going to do an inverse cosine of 2/3, which gets me, and make sure you're in radians, 0.841. Okay, because these are radian answers, right? So this needs to be a radian answer right here. But now I need to think about cosine. So cosine is positive in quadrant 1, but it's also positive, all students take calculus, in quadrant 4. Okay, so if I'm at pi, let's say 0.841 radians up here, I can reflect that across and find the equivalent of that down there. So how do I find the equivalent of that? Well, can't I just take 0.841 and add a pi to it? No, I can't. I can't do that. I can't do that. I can't do that. Don't do that. My goodness, let's think about this. This has to go down 0.841 radians. My goodness, what was I thinking? So here we're at 2 pi radians. So can I take 2 pi radians and subtract the 0.841? Yeah. Yeah, that's what I want to do. 0.841. Don't do that silliness that I was just talking about. So that gets us to about 5.44 would be my two solutions over there. Okay, so that's going to be the trickiest part because your calculator is only going to give you one. So then you have to think about the full rotation because that's just going to give you your quadrant 1 or whatever quadrant it ends up being in there. Okay, so hopefully that made sense. Sorry if I made it confusing. Hopefully I re-clarified it. Okay, so now let's go ahead and jump into some multiple angles. So now what's interesting with the multiple angles is the multiple angles are going to change your domain. So right now it's telling me that I want to solve this equation within the domain of x being between 0 and 360 degrees. But my x here attached to the tangent is not a single x, it's a double x. So that's going to change your domain, which means I have to double everything within my domain. So now my new range, or my, not range, I shouldn't say range, my spread is going to be from 0 to 720. So now I'm going to do it for 2 full rotations. So now I need to get answers for 2 full rotations. Okay, so I find it easiest to do like a little bit of substitution here. If I'm just going to use theta equal 2x, then that equation is just turning into tangent theta is equal to root 3. And we can find that. Remember when we did our trial and errors between the 1/2 root 3 over 2 and the root 3 over 2 1/2? Which one of those gave us the root 3's? Well, here if I do y over x, it leaves me with just a root 3, right? So this guy right here. So that is occurring at 60 degrees, or pi over 3. I want degrees because it's putting the actual domain in degrees in the original problem. So theta is equal to 60 degrees. So my tangent at 60 degrees is root 3. But we're not done because what did we say theta really was equal to? Well, theta is really equal to 2x. So 2x is equal to 60 degrees, which means my x has to equal 30 degrees. Okay. So we've got that. But where else is my tangent equal to the square root of 3? Well, it's also equal to the square root of 3 when both of these are negative, isn't it? And where is that on my unit circle? Well, that's down there at 240. I'm going to get rid of this so I can move over. So theta could also equal 240, which means 2x equals 240, which tells me x has to equal 120. So that's another option, 120 degrees. So there we've got, so those two represent one rotation. But remember I had to go to 720. I had to do 2 rotations. So now I have to find the coterminal angles of that. So what's the coterminal angle of 60? Well, 60 plus 360 is 420. So theta can equal 420 degrees. So here I'm just doing 360 plus 60, which means 2x equals 240, or I was going right to the answer. So 420, so x is equal to 210 degrees. And then the coterminal angle of 240 degrees, so 240 plus 360 gets me 600, which means 2x has to equal 600, which means x has to equal 300. So those would be all your degrees that x would equal to solve the equation 2 tan x equals the square root of 3. Okay, could you use the double angle identity and transfer that tangent 2x into something new? Yeah, but why would you do that? Because that would just get really, really ugly. All right, so example 13. Here we're going from 0 to 2 pi, not including 2 pi. 2 pi, it's exclusive. It has the parenthesis and not the closed bracket. So now instead of so this is kind of like the same as doing 0 has to be between, so x has to be between equaling 0, but not equaling 2 pi. But what are we doing? We're making it x over 3, which is going to change this to 0. Oops, not equal to. And this is going to change to 2 pi over 3. So these are the only values that I'm looking. So I need my values to be between 0 and 2 pi over 3. So again, I'm going to use the old trick of letting theta equal x over 3 just to simplify things. So now I'm looking for when does my sine of theta equal 1/2. Okay, well, we're at 1/2 at pi over 6, and we're at 1/2 at 5 pi over 6, right? So then when I solve that out, x over 3 is equal to pi over 6, multiplying by 3 on both sides gets us pi over 2. And then here, x over 3 is equal to 5 pi over 6. Multiplying your 3 over is going to get you, what, 5 pi over 2? But what did we say our original x needed to be between? Well, it needed to be between 0 and 2/3 pi. Well, 1/2 is between 0 and 2/3 pi, but 5/2 is not. So my only solution to that equation is pi over 2. Okay, that concludes your notes.